Today, we are going to learn a slightly unusual technique for soldering. If previously we might have been used to soldering components using solder like this, we just need to heat up the solder, add tin and flux, and then we can solder as usual. But actually, there are some unusual techniques we can use for soldering, one of which was shown in the previous video. I showed that we can actually solder using a clothes iron. So the heat from the clothes iron can melt the tin to unite the components on the PCB board so that they look neat. But besides that, there is another way, which is using a lamp. This might sound really strange, but it really happens. We can actually solder components on the PCB just by using a lamp. We turn on the lamp and the tin on the components will be soldered. How to do it? So, follow the video here. So, a few weeks ago in the project, I showed a new PCB, which is a Q-Machine PCB that I printed at PCBWay. At that time, I designed the Q-Machine PCB and ordered a stencil like this. This stencil is used to apply the tin paste so that it can fill the holes that we have provided. The stencil is very thin, even though it is strong. Although it is thin like this, the price is only $10, and we can use this one stencil many times. For the PCB, you can see that it is only $5 for 10 pieces of PCB, and the work takes only 2 days. So it doesn't take too long. Besides PCBs, we can also see other services, such as 3D printing and CNC machines. So, it's not just printing PCBs, but we can also assemble or buy them directly at PCBWay. The quality is really good, and I always use PCBWay services for my projects. Okay, this is the Q-Machine remote PCB that we videoed last month. The result is really detailed, but the components are very small, as you can see here. So, to be able to solder using the lamp and stencil that I have, we have to position the PCB like this. We make a handle for the PCB, so that when we put the stencil on it, it doesn't wobble. So, it can slide like this and can be held well because the components are really small. If it slides a bit, the tin might slip to the other side. After that, we position the stencil exactly on top of the PCB. Make sure that the PCB that we will apply the tin paste to does not slide. Then, we isolate one of the sides. What is the function of this? So that we can lift it up. I lift it up like this, fold it, and then I change the PCB to the next one. So now I can fill it, and then change the next PCB. After that, we continue to apply the tin. Here, the tin that I use is like this. The brand is Real Life. I don't know whether this tin is of good quality or not. It just happens to be the one at the electronics store near my house. It says 138 degrees on it, but I don't know what it means because the writing is in Chinese. It's like thermal paste, which is suitable for a processor. We will apply it without spilling it like me. Actually, just a little bit will do. We can use the stencil or just swipe it. I use the stencil because I have an unused one. Now, after we fill it, we clean up the remaining solder paste first, then we remove the stencil so we can see whether the results are good or not. After we are sure it is good, we move on to the next step, which is placing the components to be soldered. Placing the components here is a little tricky because it requires a very stable hand. If not, it will slide. After that, we need a lamp that we will use to solder the components. I bought this lamp for 100,000 rupees. It is a 100-watt, 12-volt DC lamp. We will turn it on using a 12-volt DC adapter. I attach it to a decorative lamp fitting, and I direct it upward to the PCB. Actually, there is a heater underneath that we use to heat it up, but we don't turn it on for now. Now, we turn on the lamp. Here, we can actually install a thermostat to turn the lamp on and off according to the set temperature, but I do it manually. I turn it on, and see if the solder has melted, and I turn it off. I turn it back on and so on. If it is not hot enough, you can adjust the height of the lamp closer to the PCB to speed up the process. Here, you can see that some of the solder has melted. Let's brighten it up. You can see that some of the solder is shiny, but some are not. Here, you can see the solder on the component's feet is already shiny and soldered very well, but the ones on the edges are not melted. That could be because the reflector I use is not very good. It is made of ordinary aluminum, not like a mirror. But if it were a mirror, it would be even better. Here, you can see the solder has melted and is shiny very well, even though the edges are not melted. I use a lamp fitting that is usually used for shop windows and a reflector made of plain aluminum plate like this. You can imitate this method at home using a 12-volt, 100-watt lamp. The price was 100,000 rupees yesterday, but I don't know if it has gone up to 120,000 rupees now. So, we are not using a flashlight for soldering. This lamp's heating power is stronger than a flashlight. Although a flashlight does not produce heat, this lamp can melt the solder paste on the PCB. So, that's how we solder using a lamp. It might be useful, and some people might think it's just for fun, but it is interesting information that you can try. Okay, that's all for today's video. See you in the next video.